All right, so next is Kevin. And so Kevin is actually the VP of Engineering at Mento. And today he's going to talk about how to actually integrate AI into production and practical applications. And there's an extract something loop. It's a really convoluted one. But it's going to be fun. I'm excited to share the patterns. And also a quick shout out for Kevin, known as K-Ball in Discord. He's involved in a lot of different things, but two things I think would be interesting to this group. One is an AI in Action meetup that they virtually meet up once a week or once every 2 weeks?
Once a week.
Once a week, and they talk about different applications for AI in production. And also, this is part of the Latent Space Discord, which Latent Space is a podcast if you're not aware. I think all of you would be interested in it, where they talk about all the cutting edge stuff happening in AI. With that being said, Kevin.
All right, you're stealing my thunder. I'm going to tell people about those things. Oh, we're good. Awesome. And then, yeah, we have this all set up. So hello, everybody. I have the dreaded after lunch spot, except no, I don't, because Josh already warmed you all up. How are you doing? Yeah? And you're awake? So this conference is really neat because we're seeing such a different variety. So I'm actually going to ask a couple questions up front before I get going here. How many of you are dealing with non-language-based AI models in your day-to-day? All right, not too many. We saw several talks that were kind of looking at this, but not too many. How many of you are using tools built on language models of some sort, whether it's code completion, something else like that? Awesome. How many of you have built an application for prototype level using those tools, or having those tools integrated in the application as a prototype? Okay, smaller, but still good. And how many have taken that all the way to production? Almost the same set. That's pretty good. So what I'm going to talk about today is in that application development space of building applications that use LLMs in there, and I'm going to talk about a particular pattern that's similar, I think, to some of the patterns that Obi was describing, but I'm going to go much deeper on one single pattern for building reliable applications. So very quick before I do that, about me, I'm about 20 years in this industry, been doing a lot of both individual engineering, management, stuff like that. As Dylan was referencing, I've been involved in the Gen AI world for about a year to a year and a half, and a lot of that has been through the Latent Space Discord online community. We started a paper club there where we could dig into what are these models actually doing and all the fundamental research, and then more recently started a discussion group on how do you put these models into production use in different ways. And if you get nothing else from my talk, but you go and check those out, those have been like the most powerful learning tools I've seen in terms of bringing myself up to speed of what's capable here. And I'm currently VP of Engineering at Mento. So the motivating problem for this talk is this idea of how do we productionize LLM applications? Because we all know how incredibly well they demo. You put something into play, you put a demo in place, you prompt it a little bit, and you're like, whoa, I just wrote 5 lines in English, and it's doing all of these different things. And that's because these things have some incredible, powerful strengths. So if we want to lay out a little bit of the fundamental strengths of LLMs, they're very adaptable, they're very flexible, they're great with unstructured data and interactions, and they're pretty good at executing or generating things based on your instructions. And so you do that, and you get your demo, and you go, and your CEO says, all right, great, when are we shipping? And you go to productionize, and you start testing all of the different edge cases, and encounter that, wait a minute, these things do great in a demo when I'm giving it something that kind of is matched with my expectations, and then an actual user gets in there, and they try to do a thing, and they ask for it something a little bit different, and you end up with examples like this, where there was Air Canada shipped a chatbot that promised one of its visitors that, yes, if you file a report within 30 days after you buy your ticket that you are going to going to a funeral or something, you can get the grieving discount, which Air Canada then said, no, you can't. That's not in our rules. And they took them to court, and they said, you know what? Your website said it's true. So you owe them that discount. You end up with cases like this, where you had an eating disorder helpline implement a chatbot inline, and they're like, all right, we don't need people. We can do this. And pretty soon it was giving harmful dieting responses to people with eating disorders because they're building on top of this unreliable substrate. And this is kind of the thing here, is that there are some fundamental challenges that are baked into the LLM architecture. Hallucination, I think Obi talked about, it's not as big of a problem as you think, but it's there, and it's a fundamental part of the architecture because they are not understanding truth per se, they're understanding language. And two words that are filling the same linguistic meaning can get substituted for each other without any reference to truth. They're black box, generally, we don't know what's going on underneath them, and they're pretty bad at decision-making or judgment. Now, there are a couple of other weaknesses that I think are true today that are not fundamental to the architecture. They're slow, but they keep getting faster, and I think that's not fundamental to what these things are. I think eventually these will be about as fast as a database call or two. And I think early on I thought, oh, they're not capable of structured outputs, but it turns out they are. We've seen this with function calling, tool calling, and you can even just ask it, hey, output your response as YAML, output your response as JSON. They're pretty good, you just have to direct them. But I don't think we're going to get away from these fundamental limitations. So that means our fundamental question for taking these things to production is how do we make a reliable service on top of a fundamentally unreliable substrate? And luckily, this is not a unique problem in engineering. Quick flashback, how many of y'all did networking protocols? TCP is a reliable networking protocol built on top of an unreliable substrate. And we do that by saying, oh yeah, any particular message can fail, but if I acknowledge and make sure that if I didn't acknowledge, I get a resend, and I have all these different pieces, I can actually build something reliable on top of this unreliable underpinning. So my next question is, what does that look like for LLMs? And this talk is proposing one pattern that I've come to, and that I see, and I'm going to share a bunch of examples, for building reliable user applications using LLMs. And I'm calling this probably too complex, I need a simpler term, but extract, validate, extrapolate loop. And we'll talk about what those pieces mean. So first off, extraction. This is where you use the LLM to extract some information. Now that might be directly from a user. We're having a conversation, it's a chatbot. It might be we're summarizing something, or we're taking verbal recordings and generating text, but we're extracting some information. This might be interactive, as it is in a chatbot. It might be asynchronous. You get notified, oh, here's your transcript, what have you. And it might be structured or unstructured. And some examples of that, well, I just jumped over myself. You might summarize a transcript. You might identify what is this user trying to accomplish. You might write some code, right? Many of us are using Copilot or something like it. Thank you for the Copilot stuff. Like, that's extracting information. It's taking something from my intent, I want to do this, and writing some code. You can also use this to pull out data. Hey, take this unstructured document, give me a CSV, whatever it looks like. So most LLM demos stop at this extract, right? And we're like, okay, great, we got the thing we're looking for. And the question is, okay, sure. And it works most of the time, but what do we do now? And so that's where I get into the next step here, which is to validate, to figure out a way to validate. And so that, quite simply, is to try to confirm the validity or correctness of whatever it is that you've abstracted. That could be a human in the loop, as we just heard from Josh. That could be a machine validation. Great example earlier, Richard, you were talking about the formal checker for a math proof. You could have something formal. It can be formal, it can be informal, what have you. So quick example, Copilot. Before I knew there was a Copilot talk, I had this screenshot. This is from the Copilot website. They don't just put your code in there. They give you a suggestion, and you look at it, and you say, yes, that's actually what I wanted. Or you can say, no, that isn't what I wanted. But you've got that human in the loop for validation. Different example, there's another coding tool called Sublayer, where they're generating code, and they have, this is an example, it's probably too small to see, but you start with a set of unit tests, and you have an AI or LLM-based agent that goes and tries to implement code to match those unit tests. And so after it's written some code, it runs the tests. Do they pass? Great, we're good. Do they not? Okay, try regenerating. But you've got this validation step in there. Or an example from my company, we're doing an AI-based coaching interaction, and when we think we've identified, hey, you're trying to accomplish this, we'll show it in a UI element and say, hey, like, is this right? Is this what you're actually trying to get to? One more example of validation that I thought was super cool. I gave this talk at one of those discussion groups, and somebody brought this up. You can actually expose the probabilities generated for each token to the user and say, like, hey, some of these we're really confident of, and some of these were pretty low confidence. Does this seem right? Do you want to change this? How do you want to do it? Regardless, once you have validation, whether it was formal or informal, the next step is then what I've been calling extrapolate. Maybe that's the wrong word, but it's basically, let's decide what to do next. We have some confirmation here. Let's figure out what it is. So you're taking action on your confirmed information. This is an opportunity, if you want, to reason, to perform some logic, whether it's code-based logic or LLM-based logic or whatever, to think about what's happening. And optionally, you can go back to the extract phase so that you end up doing this whole process again. So some examples. This is a screenshot from a company called Stately AI. They're building a state machine-based AI set of tools. It's by the same guy who did XState, which is a state machine library in JavaScript. And you might move in this extrapolate phase from one state in your graph to another. In my company, once again, here we've identified something you want to work on. We'll actually take it and put it over in another software tool. We're extrapolating it out of the LLM flow and saying, hey, we're tracking your growth plan. Here you go. So looking at that loop together, and I realized I'm racing through this because I have not seen any signs yet. So we're going to have plenty of time for questions. But looking at some examples, who here's heard of DSPy? Only a couple. So DSPy is a really interesting thing. So this is a piece of software that is essentially saying, hey, we shouldn't be handcrafting prompts. We should not be treating prompts as the final mode for programming with LLMs. Instead, we should be designing these modules where we specify, here's an example, here's some outcome behavior I'm looking for. You, the machine, go and figure out how to prompt yourself. And you can build these pipelines where it kind of goes through this entire loop of, OK, here's what I'm trying to do. Let me generate a prompt. Let me validate that against the examples that I've got. Oh, it didn't work so well. Let me try a new prompt and kind of go through this entire loop as one. Another example, this was my company. We're doing this. We'll take you through a workflow based on a coaching framework called GROW. GROW stands for Goal, Reality, Options, and Will forward. And it's basically a way to help someone who is trying to figure out what they want to do in something to get clear on what am I trying to do? Where am I right now? What are my options? And we'll kind of take you through this series of steps as we go. So now we get into kind of the interesting part, which is what does this mean for your applications as you're building these application development? I think one of the biggest things here is it means that we should be decomposing our LLM applications into lots of composable blocks. I think the days of the single mega prompt approach are probably limited if we want to take these things into production, because when you have that single mega prompt, it's really hard to kind of validate and constrain and bring things down to something that's actually useful. This is a place where I think, honestly, OpenAI and ChatGPT and their custom GPTs have led us astray, because it's led us into this world where all of interacting with an LLM looks like one big, long conversation. And if you want to do a custom thing, what you do is you set up one big mega system prompt that's taking you in a different direction, and then that becomes this whole big conversation. But that's really hard to make reliable, and you end up with all these different problems with it, where if you have a long conversation, it starts to lose the thread. It says, wait, what were we trying to do before? Or it's really hard to eval. Right? How do I make sure this is actually working well with different types of data, or as I change the model? I think it also implies that we should be looking for opportunities to validate in how we design our applications. Right? So if you're building a coding tool, you're not building that saying, hey, I'm going to write all my code there. You're going to say, hey, let me put that in front of somebody and let them check that. Or how are you validating this? Are you using unit tests to do it? We should be designing, whether it's human in the loop or formal checker in the loop or another LLM validation in the loop, we should be thinking about the ways that we're creating these things to give ourselves opportunities to validate their output. And I think another thing that several of you have heard me say in conversations today is I think we need to be elevating decision-making up to human beings. So LLMs are phenomenal at transforming text. They're phenomenal at taking some intent, or you saying, hey, I want to do this, and turning it into something actionable. But they're really, really bad at reasoning and judgment and decision-making. They have no concept of, is this a good idea or a bad idea? Is this right or wrong? To the extent they have that, it's purely linguistic. Does this match linguistic principles that we've seen? And so we should be thinking about how we design our applications to identify when there's a decision to be made. That's a form of validation. Elevate it up to a human being to make that decision. Or possibly elevate it to some sort of formal check or something that's not based purely on probabilities. So what does it get us if we follow something like this? So one is, I think it gets us to a place where we can have much finer grained control of context. So once again, going back to the GPT example, ChatGPT sort of has trained us that you have a system context, and then you have a really long, growing conversation, and that's your context. And you keep going, and it's iterating on that. But I don't think that's necessary. So if even in a conversational interface, you could have some conversation, and then take what you've done, have an LLM or something else summarize it. Maybe you validate that summary. Maybe you passively validate by showing along the side of your conversation, here's an ongoing summary that they can correct. And then use that summary as your context for the LLM call. And so once again, you get these much smaller, more contained, easily testable, easily validatable components that allow you to do it. I think this also lets you catch and course correct hallucinations as they happen. So instead of, oh, this hallucination happened and we're continuing down the road, if you're validating that, the user or the formal checker or what have you can say, no, that's not right. Let me fix that. And that might be explicitly rewriting because LLMs only know history as much as you tell them what the history is. So they could actually rewrite and say, this is what I meant. And the LLM will even think that's what it wrote. Or you can just say, no, let's start this conversation afresh, or let's loop back around, whatever it looks like. And it gets us to smaller, more debuggable, more eval-friendly prompts where if I have one step in logic that's encoded in LLM, I can then pull that out, capture it, put it in an eval, run a bunch of tests against it, automate it. Where if I have 5 different logical steps that it's deciding behind, it's very hard to test that in a reproducible way. So with that, and apologies for running too fast rather than too slow, I'm going to move into questions at this point. Yes, sir.
Thank you, Kevin. Very good presentation. So I wanted to ask you about the experience you've had building these applications at your mentoring product. So do you actually have a mentoring LLM application always supplement the role of a human mentor or coach? Or is it something that you can give it to the user, by itself? And secondly, do you actually find that you need to really customize it for an industry, for a specific individual, and how do you, do that? So these are the 2 questions I have.
Yeah, no, that's a great question. And so I'll answer the first one first. So we are, what I would say, relatively early in our process of this. So we rolled out a beta that is alongside human coaches, because our core business is human coaching and mentoring. And have been testing that, and then now are working on what does it look like in a standalone context. Now, some of the things that we've learned is that people don't look for the same things out of an LLM as they do out of a human. So we had this thing that I showed positioned as here's an AI-based coach that you can work with on this, and people don't want to interact with it as a coach. They want it much more direct. When they're working with a coach, the coach will sort of coach them through thinking about and how they can use that as a growth opportunity. Somebody interacting with the LLM is like, no, just tell me the answer. I want this thing. So we're taking that and kind of iterating on that and thinking about how can we shift the perspective so that we're giving you the answer and then the breadcrumbs so that you can still learn about it, because fundamentally we are a learning and development company. We're not a give you the answers productivity company. So that's one piece. And the second question, sorry, was...
How do you customize it for industry or person?
Yeah, so that's a great question as well. How much do we customize it for industry and person? I think where we are going with this is having kind of a set of layers. So one of our main targets right now is managers, and particularly new managers. And there's a set of very common skills that new managers struggle with and need help with. And so there we can kind of build in a set of base level tools around that. But what's great about the flexibility of LLMs is you can then expand on that and say, okay, not only are we having this sort of base level training of, okay, you're a new manager, you're probably struggling with delegation, you're struggling with giving feedback, we can have those skills baked in. We can also look at your company's competency framework and their value system and kind of pull those in and say, okay, how do I apply giving productive feedback within the value system of my company that, for example, maybe values kindness or has other different pieces on that? What does that look like differently with a company that values directness? And that's one of the things that they're putting. So you can kind of layer those different levels on top. It's not standardized at all. But once again, with the LLM context, it doesn't need to be, right? You can actually use that much more flexibly on top of it.
Yeah, so on the validation step you were describing, in the case that you have a machine doing the validation, do you typically try to have it evaluate in a binary, like yes, this is good, or no, it's not good, or do you kind of think of it in terms of a gradient? What sort of scenarios call for different approaches? Just how do you think about that?
Yeah, so since the mic cut out, I'll repeat it. So the question is, if you're using a machine to validate, are you doing binary validation or more of a fuzzy gradient-based validation? I think it really depends on your problem domain. So not to overemphasize this, but reaching back to Richard's example, in the math case, you know if it's a valid theorem or not, right? You can absolutely validate it. That's pretty binary. Other examples that I've seen are if you can sort of plug into pulling out, rather than just pulling out the tokens, you pull out the log probabilities for those tokens, and you can build a classifier that says, hey, this is very likely a hallucination or not. Now, and you can even do that in a way that gives you a little bit of a probability. This is likely a hallucination. This is maybe a hallucination. We're pretty confident this one has, very good. And so depending on how important it is for your use case that this thing be really accurate, you can be more or less stringent on that, right? So if I'm building a RAG application and I want to say, hey, this should only reference things that are in the text, I might then have it go and validate that it can do matching of strings, do some things, and put it pretty stringently. Whereas if I'm doing something like a coaching conversation, it can be much more flexible. In fact, some of that flexibility is actually valuable in that use case.
Oh yes, this kind of relates to Don Shen's talk that he mentioned earlier today. Do you guys use vector databases or let's just say like similarity search and stuff for validation? Is that a way to do that, or am I misunderstanding?
So you can. Honestly, so doing similarity search is a little bit different in this case. So you could do that as a way to load up what information you're going to then supply in that case. And you could, for example, in the RAG example, validate, okay, I'm only showing something that showed up in my search, but it's not, in this case, we're not doing too much with that. I also want to plug that you can very much layer different types of search. I think Don was referencing some of that, but most of the folks who are trying to just do naive vector search and kind of that sort of similarity are finding it's not as good. And so more and more people that I talk to are doing some combination of, they'll do a vector-based search, and they'll do a traditional keyword search, and then they'll use some sort of re-ranker on top to kind of rank those things together and find what's the most relevant. Other questions? Yes?
So for some applications where LLMs are maybe directly in the flow of the user, how would you apply this sort of EVE framework where the validation needs to come asynchronously after the fact, after the user has already used the application and seen the answer?
So that's a really interesting question. And I think you're going to have to maybe tailor a little bit more to your particular use case, right? So if it's important that what the user sees is correct, I wouldn't do an asynchronous validation. Right? Or I would tell the user, hey, I'm going to go and figure this out for you, and then I'm going to come back to you. And this is why I sort of describe it not just as an application pattern, but as a user experience pattern, because I think the way that you present this to the user needs to take into account the level of validation that you require. Right? If you're in the healthcare example and you cannot show them something wrong, then doing a synchronous interaction before you're able to validate is probably not viable. Yes?
The last question.
sorry, your last one. So I was thinking about that loop. So when you get to the validation phase, I'm assuming there could be a feedback loop to learn at some point. So how do you control for different users with different knowledge that we talked about last night? So we have junior users and sophisticated users, and how do they learn? How does it know what truth is in that sense of what to learn from?
Yeah, so that's a really good question and kind of gets to sort of a core question with all of this stuff of what is truth in this world, right? Like we really don't know. So in terms of training, like you can, like you see in the ChatGPT style interfaces, they all have this thumbs up, thumbs down. What is that telling? All that's telling the model that's training on it is like, hey, I liked this answer. Has no relevance to actual truth, but this gave me something that I think is what I needed. And I may not have any idea whether it's accurate or not, but I liked it, so I gave you a thumbs up, or I didn't like it, so I gave you a thumbs down. Maybe it was telling me a hard truth, and I gave it a thumbs down because I didn't like it, but that was actually the best answer it could have given me. So I think, like, and I hate to be fuzzy like this, but like so many things, you're going to need to look at what is your use case and what do you think truth looks like. Your validation, if your user is in the loop, might just be like, this requires somebody to actually take a look at it, or this requires it going through something else. Like I don't have there's not a like gold standard answer that I think will work on all use cases.
Thank you so much.